Hello student, I am Dada Perez. Let us be know about the Raman effect as we studied in the previous class about the Raman effect. Raman effect, when you pass a monochromatic light in a through some organic liquid like benzene, toluene, some others. So, incident through the solutions and come out of these solutions with not only a single line, single wavelength, they have a different wavelength along with the incident line. So, there is three types of lines will be come out of these solutions. So, they are called Stokes lines, another one is called anti-Stokes lines, and third one is which is a Rayleigh line, which is unmodified as it comes out of as it is incident. So, that is the Raman effect. So, this is the fifth semester related paper 6th of the Davangere University. Today, let us we discuss about how can we give the quantum explanations about this Raman effect and their applications. So, today we are learning about this session is what is the Raman spectrum and how the Raman effects can be used and how this can be quantum mechanically, how can we explain about the Raman effect. Today's lessons we can be learn how to use this Raman effect and in the futures. Let us we discuss some. Already we know that what is spectra, it is a group of intense lines with a different frequency or wavelength. Some other diatomic molecules are there, there is homonuclear molecules and also the heteronuclear molecules are there. So, you must know that monochromatic light is nothing but they have a very single wavelength. So, how can we explain about the Raman effect? So, Raman effect can be explained on the basis of this quantum effect. So, let me see. So, Raman effect can be explained on the basis of this quantum theory. So, as we see that Raman is making an experiment and also be the explanations in the previous sessions, and we will discuss some. Let incident particle, some have a incident particle which hit the molecule. So, that is this molecule and some is scattered, some energy. The incident particle having some energy E and they have a kinetic energies and they have energy h nu and moving the kinetic energy is of mv square. So, after hitting this molecule, so they scattered, the scattered molecule having the frequency that is h nu 1 and having kinetic energy h v 1 square and energy is E 1. So, due to the conservations of energy, the incidents total sum of this kinetic energy of the kinetic energy and frequency, they are all equal to the scattered one. So, this is about the conservations of. So, here move further. And some terms are is there h nu and of mv square and here the kinetic energy of the intrinsic energy of the incident photon and h v 1 and of h v 1 are the and E 1 are the kinetic energy of the intrinsic energy of the that is E 1. That is E 1. So, when there is a no change of temperature, there is no kinetic energy will be changes, means the both incident and scattered protons their kinetic energy will be get cancelled. So, kinetic energy get cancelled and that leads to be equation h nu plus E equal to intrinsic energy and h v 1 and E 1. And let me rearrange this equations. So, see here h nu is equal to h nu 1 and E 1 minus E. So, that is, let me divided by H, that leads to nu 1 plus E 1 minus nu divided by H. So, that is V is equal to, that is E 1 minus E H is nothing but delta E and divided by H. So, taking this line, the equation 2, nu equal to nu 1 plus del E by H. So, let us we discuss about the Stokes line. As we know that Stokes line is the lesser frequency than the incident one. How, let us we check. So, when the energy is rises from the higher energy level to E 1, so delta E becomes positive. So, then nu 1 is equal to V minus del E by H. So, del E become positive, that is a difference. So, V 1. So, this formula gives to, as we know that E equal to H nu, that is nu equal to E by H, that is why del nu will be taken as a small quantity of the frequency changes. So, means there is the frequency of the one of the scattered line is decreases, means if the frequency is less than the incident one, that is called Stokes line. Hence, the Stokes line will be have a low frequency or higher wavelength. That is the one of the line will be proved here. So, what about the anti Stokes line? So, when the photon is there. So, it may be fall by the emissions of the radiations, it one falls from the E 1 to, so there is energy level already excited level. So, it falls to ground level, this is ground level, some radiations will be emitted, some it loses its energy. So, when it loses its energy, so delta E means E dash minus E. So, this become negative, delta E become negative, means that is V 1 equal to minus into minus positive, that leads to positive negative. So, minus into minus plus, that is why delta E by H, and delta E by H is nothing but del V. So, means frequency of the scattered line will be sum of the incident frequency plus small amount of the frequency is increases, means the frequency of a scattered photon is more than the incident one, means it leads to a Stokes line. Hence, the line which have frequency more than that incident one, it's we know that it is a anti Stokes line. So, hence we from this line we can be easily say that, and this way how this is the reason for the in Raman effect, the incident light, even though it is monochromatic, it splits after the organic solvent is passed through it. So, then it can be, we can say that there is the quantum mechanically it can be proved that they have a two lines which are higher than and also the lower one frequencies, that is the Stokes line and anti Stokes lines, and this Raman effect. So, that is why he invented discovered this phenomena. So, nowadays Raman effect can be used in various way, that is one of the various is also be the very useful for the study of the molecular structure, about the molecular spectra, how they are arranged molecules in a system of a atoms, in a system of a molecule, how they are arranged. So, and it also be helpful for the know about the intrinsic structure of the matter, means the constitutions of the molecule, how they are arranged, how their structures will be followed, and also the homonuclear molecules rotational and vibrational energy of the homonuclear molecules, and also some others also be there useful applications of the Raman effect. So, that is the atomic mass, and their valency band length can also be calculated. How they are diatomic molecules are separated, and what about their distance between the two molecules can be calculated using this Raman effect. And also the chemical effects, how they are chemical effects can be studied, how they are used the catalysts, somehow can they helps to enhance or reduce the chemical equations. So, and also the Raman effect can be used as a complementary to the X-ray crystal spectra, because X-ray is very dangerous to use frequently. Hence, the Raman effect can be used without effects. So, there is any adverse effect. So, Raman effect can also be complementary to the X-ray crystal studies. Hence, these are very useful Raman effect. Nowadays, Raman effect can also cover all vast area of the applications of the spectroscopy. This is all about the Raman uses, Raman effect uses. Let's we see. Okay. Thank you very much.